Okay, so these next ideas are going to be helpful to us. We don't have specific problems with them, but good to know. Okay, so there's some properties of roots. First of all, if f of x has degree n, then counting multiple roots. Like on the last problem we said 2, but it's in there twice, so we said, oh, it's got a multiplicity of 2. Okay, so counting multiple roots, if it's in there more than once, then f of x has n solutions, or zeros. I'm sorry, I should say zeros because it's not an equation. Could be set to 0. Okay, sorry. And zeros. Okay. So zeros, solutions of the polynomial set to 0. Okay. So that's one idea. So if the degree, like you have an x cubed plus whatever, then there's going to have 3 zeros. But remember, you have to count the multiplicity. Okay. So you might have 1 0 in there twice, or more times even. Okay. Second, if a plus bi is a 0, then its conjugate, a minus bi, is a 0. Okay, so sometimes they call that the conjugate zero theorem or something like that. This book doesn't use that terminology, but if you've got an I in there, if you have an imaginary part, then the conjugate will also be a 0. Okay, like we had that on the last problem. We had something like -2 plus I square root 2 and -2 minus I square root 2, because we had the plus or minus thing going on, and so both of those were zeros. Okay, so you might remember that. All right, now we're going to get to the fundamental theorem of algebra, and it says if f of x has degree n, and n is greater than or equal to 1. Okay, so it's either a linear equation or higher degree than that. Then f of x has at least 1 0. Okay, so that's kind of important because then it says, well, if it has 1 0, you can say there's a factor, and then you could work with the rest of the polynomial. And then you could keep saying that till you get it all factored out, right? Okay. And you could find all the zeros that way and find all the factors that way. Okay. Let's see. I don't think I have anything else on that one. So we'll cover another theorem in the next video. I did leave something out. So it has at least, oh shoot, it has at least one, I left out the word complex, 0. Now, I have to say, that's kind of important that I left it out, but one complex 0. Now, that doesn't mean it necessarily has an imaginary answer, okay, that there's not at least one imaginary solution. It just means that it has at least 1 0. It doesn't have to be a real number. It could be an imaginary number, but it could be a real number. Remember, all real numbers are also complex numbers. Okay, so a lot of times we don't think of that when we think of complex numbers. We always think there's going to be an I in there. But a plus bi, I could be 0. It could, b could equal 0. Okay, so like 5 is a complex number. -2 plus I is a complex number. 3 minus the square root of 2 is a complex number. It's a real number, but it's complex. 7 minus I square root 5. That's a complex number. Okay, so all of these numbers are complex numbers. Some of them are real, some of them aren't real, but I just wanted to point that out.